Okay, now we will learn about vectors. In previous videos, we have seen that some quantity which has magnitude but not direction. So, examples are like time, temperature. These things has no direction. So, these quantities are scalar. Now, vector vector has both magnitude as well as direction. And vectors examples are like displacement vector, velocity vector, acceleration vector. We have studied these things in my previous videos, so I explained there what is displacement, what is velocity, everything. So, and just just having magnitude and direction does not make a quantity a vector. It also have to follow law of triangles or law of parallelogram in addition. When you will add two vectors, then you have to follow law of triangles or law of parallelogram. If two quantity, when you adding them, if it does not follow these rules, then it will not be a vector. So, like for an example, a current flowing through a wire. It has both, it has magnitude. This current has a magnitude, that some amount of current, say 1 ampere or 2 ampere. So this magnitude has a measurement. So this current has magnitude and it is flowing in a direction, but still it is not vector because it does not add. When two current flows, suppose there is a junction, suppose here it is coming 1 ampere and here it is coming 2 ampere, and then there it will be flow 3 ampere. So this current does not add in vector addition rules. So that's why current is not a vector. This is not a vector quantity. Now we will see different type of vectors. Suppose say, so it has a magnitude, suppose say it has 1 2 3 4, suppose say 4 unit, and this is according to the x axis. Suppose I took this axis as x axis. So this vector is 4 I cap, and I cap is unit vector towards x axis is called I cap, so it is 4 I cap. So this vector has a particular direction and a definite magnitude. Now say there are another vectors, it has also the same direction. Suppose this vector is a vector and there is a b vector which has also, suppose this is 4 centimeter, and then there is another vector which is also 4 centimeter, and this is also along the x-axis. So here this will also be 4 I cap. So here a vector will be equal to b vector. Okay, and if there is another vector, suppose it is also along the x-axis, but this length is not same with a, so there I can say that c vector is parallel with a vector and b vector but not equal. And suppose say there is another vector d vector which is also along the x-axis, but this is along the negative x-axis, and it is, suppose say it is also 4 centimeter, then a vector is equal to minus d vector. So this is opposite vector of a, and you can say that you can replace this all vectors along a x-axis. Suppose this is your x-axis, and you can fit these vectors along this axis. Okay, so, and in case of d vector also it will fall into the same axis. As these all vectors can be drawn along x-axis, so these vectors are called collinear vectors. That means all vectors are parallel to each other. Now, and I told you that unit vector is the, so if a vector, suppose this is a vector, and if I divide this vector by its magnitude only, here magnitude of a vector is 4 because the length of this vector is 4 centimeter, so the magnitude is the length of the vector. And now if you divide a vector by its magnitude, then you will get a unit vector. So here the a vector is 4 I cap. If I divide it by 4, then I will get only I cap. So I cap means this is 1 unit. Suppose here this is distance vector, so it will be 1 centimeter. So if it suppose say this is velocity vector, if a could be the velocity vector like 4 centimeter per second along x-axis, so this will be then 1 centimeter per second. That means the unit vector's unit will be same with the original vector unit. So the unit vector will be magnitude 1, and the direction will be same with the original vector. So that is unit vector. And if 2 or 3 or many vectors, like see this all vectors I have drawn, they all lies in the plane of the board, so these all vectors are coplanar vectors. Okay, now we'll learn how to add two vectors. Now say this is a vector, a vector, and there is, suppose this is along x-axis, and there is another vector, that is our b vector, and suppose this is y-axis, this is x-axis, and this is y-axis. And now suppose say this angle is alpha, so what will be your resultant vectors if you add these vectors? Suppose if you add these two vectors, a vector plus b vectors, what will be your result? Then law of triangle triangles of vectors says that if you make a triangle with these two vectors, suppose this, and if you join the initial point and the final point, you will get a triangle. So from initial point to the final point, if you add, then the direction will be from initial point to final point, and there I got another vector, so I'll call this vector as C vector. So A vector plus B vector will be C vector. Now suppose the magnitude of A vector, is A and magnitude of B vector is B. Now I have to find what is the magnitude of C vector and what will be the direction of it. Okay, so we'll divide it into components. Now, and how a vector can be divided by components, that we will learn after it. Okay, so now say this angle is theta, so we have to find the value of theta, and we know the value of alpha. Alpha is given. Okay, when we are adding these two vectors, we know the alpha, but we don't know what is theta. We have to find the theta. Okay, so if this is B vector, so this value, this magnitude is A, from this, from suppose say it is point A and it is point B, so from A to B this is A, suppose this point is C, this point is D, and now, and so we know that magnitude of C vector, and from Pythagoras theorem we know that magnitude of C vector square will be AC square plus CD square. Okay, and again from this triangle, from BCD triangle, we know that B vector's magnitude is B, so B square will be equal to BC square plus CD square. Now is, and this AC equal to, again AC equal to AB plus BC, so that is AB is A, and A plus BC. Okay, so this is A plus BC square, plus CD square, so that is A square plus 2 into A into BC. Suppose we say this BC is, suppose say this is D and this is F, so this will be D square, D plus D square plus F square. Now B square is equal to D square plus F square, so here you can find that mod C vector square is equal to A square, D square plus F square is B square, so this will be 2AD plus B square, or A square plus B square plus 2AD, and D is, say here, see here, cos alpha. Cos alpha means base by hypotenuse, so this will be D by B, so that means D is equal to B cos alpha. B is our known term, alpha is our known term, D is our unknown term, so D is equal to B cos alpha. So here I can say D is equal to B cos alpha. So if suppose say magnitude of C vector is C, so that means C is our unknown and A and B is our known, A, B and alpha is known, so we found C in terms of B, that is C square equal to A square plus B square plus 2AB cos alpha. Okay, so if I give you any two vectors and the angle between them is alpha, the angle between their direction, this vector has direction in this direction and this vector has this direction, So if the angle between their direction is alpha and the magnitude of these two vectors is a and b, so the magnitude of the resultant vector c will be such that c square will be equal to a square plus b square plus 2ab cos alpha. And what will be this alpha in terms of a and b? So say tan alpha equal to what? Base height by base, so height is f and base is d. Sorry, alpha we know, we have to find theta. So what is tan theta? Tan theta is height by base, so that is f by a plus d. So here you can find f also in terms of alpha and b, that is sin alpha means we know f by b, so f will be b sin alpha, so f will be b sin alpha by a plus b cos alpha, d is equal to b cos alpha, so b cos alpha. So we know b, a and alpha. From there we can find value of theta also. So if you give me any two vectors, we first, and if you suppose give me these vectors a and these vectors b, so I have to add them. So what I will do, I first will do the initial of this vector will come, I will bring this vector, the initial point of it to its final point, and the direction will be same and magnitudes also. So I will draw a parallel vector of this from the end point of the first one, then I will form a triangle from this initial point to final point, and this will be my resultant vectors. I can find this value of theta, that what angle it will make with a vector, from this formula, and what will be the magnitude of this from this formula, because I know the magnitude of because I know the magnitude of two vectors what you give to me. So thank you. And one more thing, we'll see the law of parallelograms. Suppose law of triangles and law of parallelograms are quite similar, like I found it from triangle, but if you give me these two vectors a and b, I can also find it from law of parallelogram. So what I have to do then, I have to draw a parallelogram. So first I have to draw a parallel vector of b vector from this point, and parallel vector of a vector from this point. So I will draw a parallelogram first. So then I have to add the corner points of the parallelogram. So if you don't know the law of triangle, you can also find by drawing a parallelogram and then joining the corner, and these results will be same. Thank you. Now say I have given you two vectors, this is a vector, and suppose say this is b vector, and if I told you add these two vectors, how will do that? If you follow law of triangles, then you have to draw a parallel vector of b vector from the end point of this a vector. So or you can do in another way, that is, if you try to draw the parallel vector of a vector from the endpoint of b vector, you can do that also. So now, following the law of triangles, I have to add this. I have to draw a parallel vector of b vector from the endpoint of a vector, and let's do that. Suppose this magnitude I have to follow, so this will be your b vector, and you have to join the initial point to and final point. So this is your c vector, that is a vector plus b vector. That is the law of triangle. What would be your result if you follow law of parallelogram instead? So let's say, suppose you can do exactly with using scale. I'm just doing an approximation, and in case of parallelogram, you have to draw the parallel vector of b from the starting point. Suppose say this vector is this. So say this is your b vector, and now you have to draw a parallelogram using these two vectors. So there is parallel of a and parallel of, you have to draw parallel of b vector from this point, and you have to draw a parallel of a vector from this point. Up to a point these two vectors will cross, and you have to, this is a parallelogram, and now you have to add the corners. You have to add the corner from this point. So this is your c vector, and these vectors and this vector will be same, because if this is b vector, this is also b vector, because these two are parallel, in same in magnitude and same in direction. Okay, so now say what will happen, and we know that this angle theta, we know the value of magnitude a and b, so we knew that magnitude of c I will find magnitude of c accurately from this a square plus b square, and the angle between these two vectors is alpha. So this is alpha and this is theta. So a square plus a square plus b square plus 2ab cos alpha, and the theta is tan theta equal to what was that, b, this angle is alpha, b sin alpha by a plus b cos alpha. Now let's say, what if a vector and b vector is in the same direction? So then the resultant vector will be just a plus b, then c will be a vector. If a vector and b vectors are in the same direction, then c will be just a plus b. But can we derive it from this formula? Let's see. C square will be a square plus b square. Here the alpha will be 0. So if alpha is 0, then cos alpha is 1. So cos alpha 1 So cos alpha 1, then it will be 2ab, that means a plus b whole square. So c must be a plus b. So the result is, so from this formula we are getting the correct result. You can verify it. What if a vector and b vector is opposite? This is a vector and this is b vector in opposite direction. In opposite direction, then alpha will be 180 degree. So cos alpha will be -1, then c square will be a square plus b square minus 2ab, then c will be a minus b. So if you put this b vector from end point of it, you can see it will give you, suppose we put this b vector from this point to this point, and we know that the initial point and final point, this vector will be c vector, so that will be equal to a minus b, and in both case theta will be 0, and you can verify it, because if alpha is 0 or 180 degree, sin alpha will always be 0, so tan theta, theta will be 0, and that is matching with the result we can see. So these formulas are correct. And one special case, if alpha is 90 degree, suppose this is a vector and this is b vector, in that case alpha is 90 degree, that means cos alpha is 0, so c square will be a square plus b square, so your magnitude of c will be root over a square plus b square. Magnitude cannot be negative. This will be your c vector. So, and theta in that case will be, sin alpha will be, alpha is 90 degree, that is sin alpha is 1 b, and cos alpha will be 0, so b by a, so tan theta is b by a, and you can see from here also theta is, if this is b and this is a, tan theta is will be b by a. So from this formula we can check that the results which are known to us is matching with the result we are getting using this formula. Now, so if suppose there is a vector and b vector, this alpha is changing, suppose there is a vector and b vector and this alpha is changing, so if this alpha is changing, that means the b vector is rotating with respect to a, then the resultant vector will be highest when b vector will coincide with when b vector will be in the same direction of a vector, that is alpha, when alpha will be 0, c will be maximum, that is a plus b, and when the b vector will be in the opposite direction of a, that means when alpha will be 180 degree, then c will have the minimum possible value, that is a minus b. So magnitude of c will vary from a minus b to a plus b, and it is actually mod a minus b, because a can be smaller, b can be larger, so it will be always the difference between those two vectors, difference between the magnitude of two vectors. Thank you. You can see here vector addition follows commutative law, that is a vector plus b vector will be same with b vector plus a vector. See here, a vector plus b vector is c vector, we get it from triangle's law. Now what if we add it in different order? Suppose say we add b vector first and then a vector. If we add these two, we could get c vector, so the result is same. So a vector plus b vector is equal to b vector plus a vector. So in which order you are adding these two does not matter. So that is commutative law. So vector addition follows commutative law. Vector addition also follows associative law. Let's verify it. Suppose I have given you three vectors, a vector, b vector and d vector, and told you to add them. Then you suppose one of you add a vector and b vector first, and then you add d vector with the result of this two vector. Then another one added b vector and d vector first, and then add a vector with the resultant vector of these two vectors. Now the result of u2 will be same. Let's verify it. Suppose the first one added a vector and b vector first and got c vector as result. This is c vector, and then added d vector with it, d vector. So c vector plus d vector will be f vector. And another one added b vector and d vector first, and he got e vector, and then added a vector with it. So then added a vector with e vector. So a vector and e vector will give you the same result as a vector. So these two are same. So if I give you three vectors, it does not matter in which order you are adding them. So vector addition rule follows associative law. Thank you. We have seen addition of two vectors. Now we will see subtraction of two vectors. In case of addition, we did this. So in case of addition, we did this and got c vector as result. Now we have to we knew that a vector plus b vector is c vector. We know the addition. Now we have to do subtraction. So we have to do subtraction. A vector minus b vector. What will be that? We know that minus b vector is just opposite of b vector. So we have to draw same magnitude with b but in opposite direction. The same magnitude it will have. So in the opposite direction. So now if you draw a parallelogram, then this is your a vector and this is your minus b vector from the origin. So this a vector minus b vector means a vector plus of minus b vector. So this will be your a vector minus b vector. Suppose let's say a vector minus b vector is d vector. So this will be your d vector. So you can see this vector and this vector is parallel. That means if you are given a vector and b vector, then if you draw a parallelogram, then this primary corner gives you the addition of these two vectors, and the secondary corner gives you the subtraction of this is d vector. So this is the subtraction of these two vectors, a vector minus b vector. Suppose if I subtract same vector, a vector minus a vector, then you will found 0 vector. This is also a vector. And another thing, suppose I have given you many vectors, a vector, b vector, c vector, d vector, e vector, and I have told you that add all of them. How you will add them? Let's say I first draw a vector and then I have to draw B vector from the endpoint of it, and then C vector from the endpoint of B vector, the parallel vector with C vector. Now I have to draw D vector with it, and now E vector with it. So from one vector's end I have to draw another vector, and the final product, the A vector plus B vector plus C vector plus D vector plus E vector. Suppose say the resultant vector is F vector. So the final initial point and the final point, and from initial point to final point, this vector will be your resultant vector. Okay, this is A vector, this is B, this is C, this is D, this is C. And if you just add two of them, then it will give you C vector, this vector, this, and add you. Then if you add C vector with this result, then you will get this. And again, if you add D vectors with it, you will get this vector. Then if you add E vector with this, you will get the final product F vector. So you can verify it in this way. Thank you. Okay, now we'll learn how to break a vector into its components. Suppose this is given as a vector. Now I draw x-axis and y-axis. X-axis and y-axis are 90° with each other. So let's see. So I can say that this vector is if I add these two vectors, we'll get a vector. So I can say that a vector is, suppose we say this is ax and this is ay. So we can write it as a vector is equal to ax I cap, because this direction is I cap. Unit vector along x-axis is called I cap, and ay j cap, because unit vector along y cap is called j cap. So this magnitude is ay. So I can write a vector as ax I cap plus ay j cap. So these are called components of a vector. Okay, what will be ax? Suppose this value is theta. So then cos theta means base by hypotenuse. So that will be ax by magnitude of a vector. Suppose magnitude of a vector is a, then it will be ax by a. X, therefore x will be a cos theta. Similarly, sin theta will be equal to height by hypotenuse, so that will be a y by a. That means a y will be equal to a sin theta. So a vector will be a cos theta I cap plus a sin theta j cap. So I can break any vector in its rectangular components as x I cap plus a y j cap. It can be any vector. If it makes angle theta with x-axis, then that will be a cos theta I cap plus a sin theta j cap. Okay, so with this concept we can add many vectors. We'll see that. Suppose now I have given you the same problem, that add a vector and b vector. So now we will not follow law of triangles or law of parallelograms. Instead, we will break these vectors into components. Suppose a vector is not along x-axis. Suppose say a vector is this axis. So now we will not follow law of triangle or law of parallelogram. Instead, we will break these vectors into rectangular components. This is x-axis, this is your y-axis. Suppose we will draw first a vector and we will break into x and ay. Suppose if this is theta, if this angle is theta, then it will be a cos theta and this will be a sin theta. Similarly, we can break b vector also. Okay, so in this way, if we try to add these two vectors, it will be a vector will be a cos theta I cap plus a sin theta j cap, and b vector will be, suppose this angle, the angle b vector makes with x-axis is phi, then it will be b cos phi I cap plus b sin phi j cap. So along x-axis the components will be only ax and bx, so that is x plus bx I cap plus ay plus by j cap, that is a cos theta plus b cos phi I cap plus a sin theta plus b sin phi j cap. So in this way, if suppose I have given you to add many vectors, suppose this is c vector, suppose this is d vector, suppose this is e vector, suppose this is f vector, so you can take a rectangular coordinate and then you can draw these vectors. Then you can find x components of every vectors. Okay, suppose ax plus bx plus cx plus dx plus ex plus fx, all these components you can find, and this will be, suppose say rx, this value, and similarly you can find y component of every vector. You can find y component of every vector. So suppose those magnitudes, those y components will be ay plus by plus cy plus dy plus ey plus fy, and these will be just values, those will be just magnitudes values, so you can easily add them. Okay, this dy is this dx, ex and fx, these values will become negative as these are in negative along negative x-axis, so these values will be negative, dx, ex and fx. Okay, then you add them and the final product, the final r vector, the resultant vector will be rx I cap plus ry j cap. That means the magnitude of r will be root over rx square plus ry square, because the resultant of these values, rx will be along x-axis and ry be along this axis, so the resultant of these two will be r vector, and the angle it will make suppose say this angle is psi, then tan psi will be ry by rx. You can find value of rx and ry from this formula. So in this way effortlessly you can add any number of vectors. Okay, now say what will be a vector in 3D? Vector in 3D. In 2 dimension we have seen only I cap and j cap, that is x axis and y axis. But in 3D we'll see and another axis, and these are always 90 degree with each other. That's why these are called rectangular coordinates. Now suppose see this is your x axis. Suppose say this is your x axis, this is your y axis. These are in the plane of board, okay, and 90 degree with each other. So if this is x axis and this is y axis, then this will be z axis. That means suppose say if this is x axis and this is y axis, that means if this direction is x axis, this direction is y axis, then this upwards direction will be z axis. This is x axis, this is y axis, then z axis will be along this side. Okay, so in reality in 3D this will be x axis, this will be your y axis, and this will be your z axis upwards. Okay, now and see all of these axes are making 90 degree angle with each other. This angle is 90 degree, this angle is 90 degree, okay, and this angle is also 90 degree. X, y and z all makes angle 90 degree with each other. Now in 2D if I try to draw 3D, okay, then we draw like this. This is our x axis, this is y axis, and this is x axis, this is y axis, and this is z axis. So this is 90 degree, this is also 90 degree, and this is also 90 degree. In 2D actual drawing of 3D is not possible, it's imaginary. Okay, so you have to imagine that the angles between this axis are this x, y and z all are making 90 degree angles with each other. Okay, so this is 3D. So if in 3D if you draw a vector, suppose in 3 dimension, this is your x axis, y axis, z axis. Unit vector along x axis is I cap, unit vector along y axis is j cap, unit vector along z axis is k cap. So now if you draw a vector, suppose say this is a vector, and if you break into components, then this is along x axis, this is ax, along y axis this is a y, and along z axis this is a z. So a vector will be ax I cap plus ay j cap plus az k cap. Okay, first if you add this ax and ay, first if you add this ax vector and ay vector, then ax I cap plus ay j cap, then with parallelogram law you will get this vector, and then if you add this az k cap, this az k cap, then you will get a vector az k cap. With this if you add az k cap, then you will get a vector. And magnitude of a vector will be root over x square plus ay square plus az square. Okay, why so? Because this magnitude, you know, suppose this is suppose say this is axy, then axy will be root over x square plus ay square. Okay, so that, and s square will be, these are 98, this z az cap is 90 degree with xy plane, so these are 90 degrees with each other, so s square will be axy square plus ay square, and axy square means x square plus ay square, sorry, this is az square plus az square, so s square equal to x square plus ay square plus az square, then a means root over x square plus ay square plus az square. So in this way you can find it. Okay, thank you. Okay, now we will see multiplication of two vectors, a vector and b vector. Suppose this is a vector and suppose this is b vector. So if we want to multiply these two vectors, there are two kind of multiplication. One is called scalar product or dot product, and this is represented as a vector dot b vector, and it is defined by mod a vector, that is magnitude of a vector, into magnitude of b vector into cos theta, where theta is the angle between these two vectors. And suppose if I break these vectors into components, suppose a vector is xi cap plus ayj cap, and b vector is bxi cap plus byj cap, then a vector dot b vector will be xi cap plus ayj cap dot bxi cap plus byj cap. Now I cap dot I cap is 1 and j cap dot j cap is also 1, but I cap dot j cap or j cap dot I cap is 0. So axi cap plus bxi cap will be x into bx, I cap dot I cap is 1, plus x j cap dot I cap is 0, so x by I cap dot j cap is 0, so ay into by, j cap dot j cap is 1, so ax bx plus ay by. This is the dot product. And another one is cross product. Okay, another type is cross product or vector product. In scalar product you can see a vector dot b vector, these two are vector but the result is scalar, ay by. You can see that this has no direction, these two vectors has direction, but the product of this has no direction, so that's why it is called scalar vector, scalar product. But cross product is represented as a cross b, and now it will be, it is defined as mod a mod b magnitude of a vector into magnitude of b vector into sine theta, where theta is the angle between these two vectors. And if you break these vectors into components, suppose a vector is your x, suppose if these are 3D vectors, then what you will do, xi cap plus ayj cap plus azk cap, and b vector is bxi cap plus byj cap plus bzk cap. Now the cross product will be, suppose it will be Now we know that I cap cross I cap, cross of the two similar kind of unit vectors is 0, or j cap cross j cap is also 0, k cap cross k cap is also 0. And suppose this is your I cap, this is j cap, this is k cap. If it goes clockwise direction, anti-clockwise direction, then I cap cross j cap will be I cap cross j cap is k cap, j cap cross k cap will be I cap. If it is goes anti-clockwise direction, then the results will be positive, or k cap cross I cap will be j cap. But if it's clockwise direction, suppose say I cap cross k cap, I cap cross k cap, then it will be minus j cap. Or say k cap cross j cap, then it will be minus I cap. If it say suppose j cap cross I cap, then it will be minus k cap. So here ax bx I cap cross I cap is 0, I cap cross j cap ax by I cap cross j cap is k cap, plus ax bz I cross k is minus j, so it will be minus ax bz j cap. Again ay bx j cross I is minus k cap, ay bx k cap minus k cap, and j cross j is 0, ay bz j cross k is I cap, j cross k is I cap, so it is I cap. Now k plus az bx k cross I is j cap, so this is j cap, plus k az by k cross j is minus I cap, so this will be minus I cap, and k cross k is 0, so now I cap, this is I cap and this is I cap, so ay bz minus az by I cap, plus this is j cap and this is j cap, so az bx minus ax bz j cap, plus this is k cap and this term is k cap, so ax by minus ay bx is k cap. So to find cross product, there is another shortcut method, that is a cross b is I cap cross j cap cross k cap. If you know about determinant, then about determinant you will learn it from mathematics course, then you can find it easily. X ay az bx by bz, then you can check it, like in determinant it will be I cap ay bz minus byaz, see ay bz minus byaz, okay. Then minus j cap, you have to take it minus j cap ax bz minus ax bz minus bx az, so if you take minus outside, then here one minus will come, so minus az bx j cap, and plus k cap into ax by minus bx ay. So this is how we found scalar product and cross product. Thank you.